Okay, so I've started the recording now, and yeah, so that's basically proof that I have done. And now I'm gonna, at least I'll try to put all the recordings in the Team channel under the same conversation. But yeah, let's see how that goes. I have posted the link to this channel, and I think only 45 of you have joined out of 90. So if you have friends who have not joined this Teams channel, you know where the link is. You can, or if you want, I can post it again here. But tell your friends to join in this link. This is for all C1 computer networks course. So anybody who's in C1 slot computer networks, this is for them. So if you've joined this meeting, they've probably already joined this team. But yeah, just to make sure. Okay. Uh yeah. So what we're going to talk about today, CAT1 questions. Uh wait, let me start sharing. Mhm. Yeah. So CAT1 questions, and we're gonna do it one by one. I think that your CAT1, I don't have the list of how well everybody did, but it seems like a fairly doable paper from what the questions it's sent me. hmm Where are they? Let me just bring up these questions. Yeah, that is the first, that is this is so what I've got is this is the third question that we had in your CAT1 question. I think I want to start with this because I think it's an important question. It's maybe a question that people might have doubts about. And I tried to solve this question too, and I did get it right, but a lot of the reasoning that was behind my answers needed to be changed. So it's something it's a quite good question that you need to remember and need to remember. Okay, so the question says for each one of the following operations on remote server, discuss okay. For each of the following operations on a remote file server, discuss whether or not they are more likely to be delay sensitive or bandwidth sensitive. So what this basically means is you have files on a remote file server. So whatever you're going to do, whether it's opening a file or whether it's reading or whatever, it's going to take time because it has to be transferred. And you need, so this data going to be transferred. You need bandwidth over this network. There's going to be delays over this network. All the network parameters that you learned, they will come into play from your remote server to your, let's say, host computer. So that's basically what remote file server is trying to tell you. Discuss whether they're more likely to be delay sensitive or bandwidth sensitive. That means, let's say you wanted to you wanted to transfer data from the remote to the host. Would the amount of bandwidth on this network be responsible for how the operation was going to take place? Or would how fast the data travels across this network be responsible? So delay is basically the speed. It's going to be about the speed. So, oh wait, let me just, uh, mhm, right. I think it's easier. So delay is going to be about speed and bandwidth is your network capacity. So delay is speed, bandwidth, network capacity. And that's basically all you need to know to answer this question. Okay. So the first subpart says to open a file. So what do you need to open a file? let's say you have a file. Let's say you have a Explorer with many files, and all you want to do is click on one particular file and open it. What kind of data are you looking for? Are you looking for the contents of the data? No, you don't need the contents of the data. All you need is like the directory. So I'm just going to put whatever directory it's from. You need a directory, and that's all you need. You just need to transfer that information from the remote to the host. So you're not really looking at capacity. It's more dependent upon the speed, right? So the operating system of the host, all it needs to do is get the data to open the file and then just open it. So all what you're looking is like whatever protocols you learned about confirmations between you during data transfer, that's all you need. So opening a file is going to be, I'm just going to write delay sensitive. That's how, yeah. Next, reading the contents of the file. This is a little different because what do we need to read the contents of the file? So when you read the contents of a file, you're going to take a file from your remote and then you're going to display it on your host. What kind of data? So again, you have to ask, what is the data that you need to transfer? Do you need just the directory? No, you need something more than directory. You need directory, plus you need what's the content. So what's inside the file, right? And when you're going to transfer the content, now are we thinking about speed or are we thinking about capacity? It needs to have capacity because you're transferring a large percentage, a large amount of data to the host. And that's basically why it is, you have a file, you need to transfer everything, even if the speed is not so good. So why is it not speed sensitive? Why is it not delay sensitive? Even if the speed is bad, it's more important that you don't lose file data. Let's say you have a file with 100 lines and only uh, the first two lines get passed and then the last one doesn't even reach the server. That's not good. But if you have to wait for a little time for it to finally read, you would do that, right? So it's more important that it's bandwidth sensitive, that you have enough bandwidth, and that makes it bandwidth sensitive. Okay. The next one is listing the contents of the title. This is something that is different from the other. So you need the content, yes, but you also need what is inside these places, right? So you need to transfer the directories and you need to transfer the content. It is okay. Anyway, you need both the directories where everything is placed, and you're going to be looking at the content. So we understood that when you have directories, it is all about confirmation. It's all about speed. So how fast you can get that confirmation, but where the file is, about where the directories is, where the folder structure is. It's all about speed. And content we saw, it's all about capacity because if you have 3 lines and the first two get read and the last one doesn't, then that doesn't make sense. You need to have all of the data transferred. So when it's content, it's going to be bandwidth sensitive. And so yeah. And so for listing the contents of the directory, it is actually a special case of both delay and bandwidth. Okay. That's because you're listing the contents, you need the contents and you need the actual what those things say. What are the file names that you need to list. So this is an example of something that's both. That's what makes this question interesting. The B is display the attributes of a file. Now again, when you're seeing the attributes, again, so what is attributes of a file? What does it mean when you say attributes of a file? If you use Linux, you would know you can see attributes like permissions. Wait, so let me like permissions. You're going to see attributes like storage, like how much space it takes, the file. You're going to see it where the location is. would you need to know the directory of where the file is for these? Yeah, because you need to know where the location is. You would need to know. So this is important. Directory structure is important. Would you need to know the content of the file? Yeah, because storage is there. So this is another example. Let me change this again. So as you can see, it's similar to the previous example. This is also something that's both delay sensitive and bandwidth sensitive, displaying the attributes of the file. And finally, downloading the file. Downloading the file is something where where you need to have. So it seems like this downloading the file follows the rules of delay and bandwidth sensitive. But if you look at the directory, when we needed to know the attributes of the file, like how big the file was, what are the permissions of the file, all those kind of things. Even when we did opening the file, when you need the directory structure, where that file is located, you needed, so that was heavily dependent on speed, right? But downloading the file, you're looking mostly at the file itself moving from the remote server to the host. What I want to say is it's more about what's in the file. So you have bits in the file, and all those bits need to be moved from the host to the remote. And we're not interested in permissions or attributes or storage or any of these things. We're not interested in listing the content of the directory. We're not interested in opening the file. So it's nothing to do with your delay, the previous delay sensitive events. It's just moving content from the host, moving content from the remote to the host across the network. So it's only content related. And that means it's only capacity related. That gives us bandwidth sensitive. These are the answers that I have. You could say, I mean, you could argue that downloading was also delay sensitive, um, based on how big the file is. And I think if you had a good explanation for, even if you're going to do plus let's say plus D also, and with plus delays, if you had a good explanation, you could. But I think definitely for the first three, it is pretty straightforward, right? And you could add plus delay sensitive. But if you would say that downloading was only delay sensitive, that would cause a problem, right? That would not be right. Okay, that is the first question. Anything you want to ask me, you can put it in chat, or you can unmute and talk to me. I think it's a question that, so where this question came from, maybe you know, maybe you have found it, maybe you haven't. It's basically, or maybe I'll show you the textbook where that question came from later. But let's move on to the next question. Uh, this was, I think it was the first question. Of the CAT1. It was convert and find the CRC for data, and you're given this data, and you're asked to use the polynomial function x raised to 7 x cube plus 1. Okay, let's quickly work on this. This is actually straightforward. So the numerical questions are more straightforward than the other one. Then like the other question that we saw, the theoretical one. And Yeah, we can work on this here. If you'll give me a minute here. Mm, yeah, yeah, sorry about that. Okay, let's move on to this question. So this one is basically going to check how, right? Yeah. So how whether or not you know how to do CRC calculation. So CRC calculation is all about binary division. So when you see CRC, you have to remember that it's about binary division. Okay, let's try and solve. So first thing you need to know is that x raised to 7 x cubed. So we you have so you know in division you have a dividend, sorry, divided by a divisor. And when you're given a CRC question, your data, that is your capital D, your divisor, dividend, sorry, and the polynomial function is your divisor. And so the first thing you need to do is convert this into binary format. Um, and so way how you do that is, so let me just first write it down. So space 0, 0, 0, 1, 0, 0, 1. And it's actually pretty easy. So your each number represents the power of x. So x7 is so this is a coefficient of that particular power. So x7 raised to the power of 1, x6 not there 0, x5 not there 0, x4 not there, x cube is there coefficient 1, x2 not there, x raised to 1 not there, and x raised to 0 is there 1. So that's how you get this one. So that's basically your divisor. Your dividend, what you will need to do is you will need to add the number of zeros to the dividend, which is equal to the greatest power of the polynomial. So basically here greatest power is 7. So take your divisor and add 7 zeros to it. So that is going to be repeated here. So 0, 1, 1, 0, 0, 1, and now 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Yeah. So 0, 1, 1, 0, 0, 1, and then 7 zeros. And so all you need to do now is take these two numbers, divide. It's that simple. Just that. So now let's try dividing this. Mm, I'm gonna try and share, share. Hopefully we can divide it fast enough. So long division, right? And I'm going to add here. So here's going to be our quotient, and we'll sort of mode up. So in binary division, we generally start with the first leftmost non-zero value, which is here. It's this one. We use that, and what we do is we uh we do XORs, right? So let me start. So I'm skipping the first. So as if even if it was in proper noun division, you're going to skip a zero in the front. Yeah, so it's the same. And you take this number, let me take this divisor. So I'll show you the first time and then it'll become easier. Take the divisor and then write it over there. Right? So undo. Let's just copy the divisor. So one, I think it's yes, 1, 0. 0, 0, 1, 0, 0. Yeah, then you have that. So that's the first step. Now, how do you the normal long division? You would subtract the two, but in here we do XORs. So you should know how an XOR works. So 0. I'm just gonna write X. Okay, let me write here 0 XOR 0 equal to 0. 0 XOR 1, 1, 1 XOR 0 equal to 0. Is equal to 1, sorry. And same 1 XOR 1 equal to 0. So following here, we can solve this. This should give us 0, 1, 0, 0, 0. So 0, 0, then 1, finally 1. And then what we can do now is bring down the remaining. So you're gonna skip, you're gonna find this is 7-digit, and you cannot put this 8-digit number here, so you're gonna have to bring down one. But then you can see it's actually less than the value. So you could stop here with this as your oh no, you can, it's not less, so you can bring this down. Okay, so then we have to go another round. So yeah, sorry. So 1, 0, 0, 0, 1, 0, 0, 1. Oh, I made a mistake. I did not need to take the first 0. Okay, and again now XORs. Mm, okay, let's XOR. So 1 and 1, 0, 0, 0, 0, 1, 0, 1, 1. And now you see that this 4 digits, so now we bring down the next 0, so it's going to be 0, 0, 0. And that's basically it. So you have 7-digit number here and 8-digit number here. This is your remainder. This is your CRC. Now, how do you check the CRC? You'd have to put this back into this problem. So what that should be is we have 1, 1, 0, 0, 0, 1, 0, 0, 1. That's the divisor. That's, yeah, the divisor. And you have here 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0. Mm, now you do the same thing. One, you're gonna copy the device. 1, 0, 0, 0, 1, 0, 0. Taking the XOR. So it's actually going to give you 0, 1, 0, 0, 0, 1, 0, 0. And oh yeah, and so you're carrying forward the one from the bottom. And you can see this is going to fit exactly into this remainder, the divisor. So let me just draw the division. So it's actually going to fit exactly into this. So you could write it down and eventually you'll get your remainder as 0. And that's how you check CRCs. Yeah, that's all for this question. What you're required for this question is to find this, put that into this, like here, and then get a 0 value. Of course, this is not finished. You would have to put this again down here. You get again 0, 1, 0, 0. You do XOR, it'll all become 0. I'm just going to skip that here, but that's how you would do it. Okay, we do not have much time left. I'm just going to go to the last question really quickly. Yeah. Oops. Yeah. This is the second question, the last question that we're going to take for this question. Complete 16-bit checksum for string Chandra. ASCII value for A is 97. How do we do this? The first step in calculating checksum, so checksum is also a numeric question, right? So it's going to be straightforward. There's going to be one answer, and that's it. What would have confused people would maybe be the 16-bit, because usually we calculate 8-bit. And 16-bit means you have 16 bits of space for your checksum value. And I don't think we'll have time to solve it fully, so I'll start it and then I'll post this. I'll post this entire OneNote in Teams channel. I will take and I'll post if we don't finish it in time. I will take it and post it on Teams channel. Okay, so the first step, what we're going to do is you need the ASCII values because you need the bit binary form of this word Chandraya. How do you do that? You know, A is, oh no, it's not capital A, it's small a, 97. B would be 98. And then if you went down, not capital B, small b, yeah. If you went on for Chandra, you would see, you'll get a list of values, right? So I have, so I did all that work. And so Chandra would actually, so C would be, uh, yeah, C would be 99. And if you convert that to binary, you will get, so 110000 1. That is 99. And the D, and I was just going to give me capital again. 104, which in binary 110100. If you're wondering how you can calculate the proper form to the binary form quickly, if you have a scientific calculator, you can find out how to do it, and it'll make this faster. You don't need an ASCII table. Okay, and so what checksum does is basically it's going to be addition. So let me show you. So you're gonna, oh sorry, not D, H, yeah, because D would not make sense. Yeah, so basically what you need to do in CRC is in checksum is to add the binary values. So 0. So I'm just going to do this very quickly. So that was the value of C. We didn't make capitals. So 1, 1, 0, 1, 0, 0, 0. That's the value for D. And what you need to do is add. And so you should know the rules of addition. Let me just put that here. 0 plus 1 is 1. It's actually 0, 1. So there's no carry in that. And so by commutativity, that would be the same. 1 plus 1 equal to 1, 1, 1, 1, and 0 plus 0, 0 plus 0 plus 0 is equal to 0, 0. Okay, this is the rules of binary addition. So here I'm just going to quickly write it. If you would solve it, it would become 1, 1, 0, 0, 1, 0, 1, 1. And what you do in the next step is take the next value. So you have A, which is 97. The binary value of 97, 0, 1, 1, 0, 0, 0, 0, 1. So this is representing A. When you add it, you will get 1, 0, 0, 1, 0, 1, 1, 0, 0. And if you look here, there's actually a carry forward of 1. This is 9 bits. And usually if this was an 8-bit addition, we would add it to the front. But it's not an 8-bit addition, it's a 16-bit addition. So instead of adding it and computing, we would instead take the next, which is n. And n is 0, 0, 1, 1, 0, 1, 1, 1, 0. That's n. And you would go on. And I'm just going to skip a few steps here because I want to finish this before I leave. But when you would skip it, finally what you would get after all your addition should be, at least according to my calculation, it should be 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. That should be a checksum. Oh, not yet. So this is the value you would get. And then you would have to take the inverse of this. So you would have to take the ones complement. So let's just basically flip all the bits. 1, 0, 0, 1, 0, 1. That's your checksum. And so when you do the calculation again, this time you would not get, you would get 11111 if you would to replay this, and I'll post this on the Teams. But since we are out of time on a Zoom meeting, I am going to say thank you for everyone who joined. Make sure you give your attendance and the feedback form. Right? Okay. Thank you everyone for joining. You may now leave and I will end the session.